I'm a colorblind artist, and rendering is sometimes a challenge for me because I want my viewport and my editor to look the same, and I want whatever I view on my phone or my TV to also look the same. So, I'm going to take you through my experiment rendering in Unreal Engine 5 all the different file formats and flavors of color spaces and aces and all of the fun things when it comes to rendering in Unreal, so then we can settle what file format should you render in. So, without further ado, let's go into Unreal and talk about that. To get it out of the way, I ran a bunch of tests to figure out that the best render format to render out of Unreal Engine 5 is 16-bit EXRs. If you're doing advanced things such as compositing and Cryptomattes and multi-layer stuff, you should render in the PIS format. If you're only doing color grading, adjusting the curves, the highlights, the shadows, you can render in DWAA or DWAB. For the rest of this tutorial, we'll call them DWAA or DWAB. For PIS format, the file sizes are about 4 times larger, and again, if you're just doing color grading, DWAA or DWAB is fine. Now, I should give credit where credit is due. A Mr. William Foucher on YouTube has a wonderful tutorial all about aces and color grading a beautiful shot in Unreal Engine, but today, my goal is to figure out why people should render in EXRs versus JPEGs or PNGs or AppleProRes. So, let's dive into Unreal and talk about how to set up Unreal to render with OpenColorIO. So in your content browser, you can right-click and scroll up to the Miscellaneous tab. You're going to scroll down and you're going to find OpenColorIO configuration. Add that, and we're going to add OpenColorIO. Now, you need to download an OpenColorIO config file. This is the GitHub page of the OpenColorIO ACES configuration file. Now, what you need to do is click on ACES 1.2 config, and then you're going to download the OpenColorIO ACES 1.2. Download this, put it somewhere on your computer where you'll have access to it regularly throughout the next couple of years or so. These things will change over time, but right now, let's just work with this workflow. Eventually 1.3, 2.0 will come out. We're just going to use 1.2 for now because it's the easiest and most stable. With OpenColorIO downloaded, we're going to put this on my desktop, but you should not put it on your desktop. I'm just going to do it for this tutorial. I'm going to find this, move this around, put it on the desktop right there. Now, we're going to extract it. So I'm just going to extract it right here. Extract all. Doesn't really matter. Make sure for you save it in a place that you will remember. And the folder should look like this. And when you go in, it's going to have this ACES 1.2. Click on that. This is the file we're looking for. Now, we need to bring this into Unreal. So the way we're going to do that is go back to Unreal, double-click on the OpenColorIO object that we just made, and this window will pop up. This window is basically saying, where is this configuration file? And we need to add some color profiles to this. So we're going to click on the 3 dots, find our desktop or wherever you saved it. I'm going to go to my folder, open up ACES 1.2, add this config. Cool. Now we need to add some color spaces to this. So what we're going to do is we're going to add 4 objects here. 1, 2, 3, 4. Now, for you, you might actually need 3, but I'm going to do 4 because we're going to do some experiments for science. So we're going to click on the drop-down menu here, and the first one we're going to add is Utility and Linear sRGB. And the reason why we add the Utility Linear sRGB is that is the standard pipeline for color in Unreal. If you talk to some super smart peeps, they might have something different internally at Epic Games, but we're not those peeps, so we're going to use what we have here. Next, we're going to add an output. So we're going to scroll down to output and add Rec 709. We're going to add another, go under ACES, we're going to add ACES CG. Now, this 4th one I have here, index number 3, is optional. This is going to be my personal preference, and I typically shoot on Sony cameras. So I'm going to add an input Sony S-Log3 S-Gamut3 Cine because I shoot on Sony cameras and that's the log profile I use. If you're using a specific camera, you might use something different, but I like this. Sometimes I might integrate some video footage with my CG footage, and I just want the color pipeline to match. Once that's done and we added these objects in our desired color spaces, we can hit save and we can close this window. We don't need to do anything else here. Now, if we want to view this in our Unreal Engine viewport, what we can do is scroll up to the lit option here. We're going to go down to OCIO display, and first we're going to select an OCIO asset. So we'll just add that thing we just made, and we're going to enable it. Nothing's going to change. Now, like I said earlier, Unreal works with utility linear sRGB, so we can just add that. Nothing's going to change because it's the standard Unreal viewport, but we're going to output it to, let's say, just hypothetically, Rec 709. It's going to change the look a little bit. Now, I choose to work with Rec 709 because that's a good standard for a lot of monitors and phones and whatnot. Your final output may be different. So generally speaking, I work in Rec 709 and I do all of my lighting, my animation, my rendering. I would like to final output in Rec 709, so I work in Rec 709. So I have my OCIO display for when I'm working in Unreal Engine set to utility linear sRGB. Now, rendering in Unreal, we're going to set it to ACES CG. We'll get to that in a second, but this is a mistake I made. I would work in ACES CG, and I would try and do all of my color here. I don't recommend doing that, and I did a spot where I worked in ACES CG, and it was kind of gross at the end of the day. The client was happy, but I was like, these colors are off, and I don't know why. So, don't work in ACES CG. Now, just for demonstration purposes, if you want to look at a log space and work with, say, live action footage that's also shot in log, you could also take your viewport and look at it in a log space, but I also don't recommend that. I recommend either working with the Unreal Engine's default flavor, sRGB, or setting your output in Unreal to Rec 709. Cool. So now, let's say we wanted to render this shot from Unreal with ACES or the best color pipeline. What we're going to do is we're going to go up to our window, cinematics, movie render queue. We're going to add whatever shot we're working with, and then under the settings, for this pipeline to work, you need to use EXRs. Just use EXRs. We're going to get rid of the JPEG sequence. We're going to add 16-bit EXRs right here. And then for this pipeline to work, we also need to add our color output. Now, 16-bit EXRs, like I said earlier, DWAA or DWAB are fine. For the color output, nothing's here, but we have to click on this little arrow, and it's going to give us a little drop down. We can add the OCIO configuration file by clicking this drop down menu, enabling it. Scrolling down the color config again, we're going to select the object that's in this window here. You should have made this in your content browser. Then we're going to add the source color space. Like I said earlier, this is going to be utility linear sRGB. And then the destination color space is not going to be Rec 709 because we're going to work in ACES. So we're going to set this to ACES CG, and you're going to hit accept, and you're going to do all of the other render settings that you need to do. If you need to add anti-aliasing or console variables, whatever else. This is the color pipeline I work with in Unreal, ACES CG. Now, if you don't want to deal with that nonsense and learn about ACES, the number one thing I recommend doing is disabling the tone curve. If you disable the tone curve, it's not going to do any fancy tone mapping in Unreal Engine. I know those are complex color grading things that even I don't understand as a colorblind artist. Truly, my goal is to get my Unreal Engine viewport to match my viewport in DaVinci Resolve or After Effects or Premiere or whatever else. For DaVinci Resolve or After Effects and the ACES workspace, disable the tone curve or work with ACES. Once that's done, you can render your shot, and then we can start talking about my wonderful science experiment so we can figure out what file format will give you the best results. Now, before we go to DaVinci Resolve, if you don't know how to render in Unreal Engine, check out this video, shameless self-plug, gives you my tactics for rendering in Unreal Engine. With that out of the way, let's go over to DaVinci Resolve and talk about science. So on this DaVinci Resolve timeline, I have all the versions of renders I made in Unreal Engine with my Uncanny Jags MetaHuman and a color card. I also have a handful of images that I exported out from the Unreal Engine viewport using the high resolution screenshot option so we can see what different flavors of color profiles look like. So we have the Rec 709, which is what I work in most of the time. We have no color transformations from Unreal, which is just the standard linear sRGB. And then we also have ACES CG, which I don't recommend working in, but it's good to have just for this experiment. So in this timeline here, what we're doing is we're looking at the EXR sequences first, followed by the PNG sequences, the JPEGs, and AppleProRes. So the way we're going to test this is by overlaying these images on top of the footage. And when you set the blending mode to difference, it's going to set all the pixels that match to be black. So if I turn on this Rec 709 timeline here, we can see that something weird is happening. But if I set the blending mode to just normal, hey, it looks normal. Likewise, if we were to look at some of these other ones, like the no color transform, turn that on, and it looks pretty normal. But if I set it to difference, you're going to get some nightmare fuel. Now, how does this apply? Well, like I said, we want the pixels to match as close as possible. So I'm going to turn all that stuff off for now. And now, let's go over to the JPEG sequence with no color transforms right here. And we can see, looks like a fine shot. And if we turn on the no color transform option on the very top, and we set the blending mode to difference, all of the pixels that match are black. And right now, I really want us to look at the color card. I'm aware that there's some other weird grossness happening in the rest of the image. That's because the Unreal viewport, we're dealing with LODs and high-level texture detail on the metahuman. Really, I want to do this test looking at the color card and see how much of it matches. Because when you render from the Unreal Engine movie render queue, you get better quality because you're turning off other game real-time features so that you can get the best cinematic quality. So, with that out of the way, let's talk about EXR sequences. Now, before we go any further, I do want to say that there's a lot of other variables that are worth considering. First off, some of the color differences that I'm getting into are almost imperceptible between the renders. So, who does this affect? It is going to be those freelancers who work with brand colors, or perhaps a stingy and particular creative director who wants the exact green or red or blue or whatever else. This information is for those people who have to deal with weird color situations 10% of the time. Granted, I do think it's worth having a good foundation of these color pipelines because there's a lot of different monitors, there's a lot of different ways to view content, and ideally, as artists, we want our content to be viewed in the best light. So, let's talk about the Rec 709 transform and the EXR sequences. So, the way we're going to work with ACES is the ACES color transform. So right now, whenever you bring a shot from Unreal Engine into DaVinci Resolve or After Effects and you render in ACES, it's going to look like this. The colors are going to be really saturated. It's going to look really contrasty. It's not going to look as good or match your Unreal Engine viewport. And again, that's what I'm trying to get at. I want my renders to match my viewport. So, to do that, what we're going to do is we're going to go over to the color tab and we're going to add some ACES transform nodes. Now, I will also mention for those of you who do use DaVinci Resolve, I am using, if you go down to the cogwheel in the lower right hand corner, the color management settings, we are using the default DaVinci YRGB color science. You could use ACES if you want to, but I'm assuming that most people who are just getting started with DaVinci Resolve just want to use the defaults for now. So let's fix this shot and get it out of the ACES color space and make it look less bad. So we're going to add an ACES transform node here. We're going to plug in the first node. And for the input transform, we're going to set it to ACES by hitting A on the keyboard and scrolling down. Find ACES CG because that's what we rendered in. Then we want to set the output transform also to ACES CG because we're not really doing any transformations here. Next, what we're going to do is we're going to go back to our library. We're going to add another ACES transform, and then we're going to set the input to ACES CG again. Find that, and then we're going to set the output to I want Rec 709, so I'll hit R. You could use sRGB if you want to. Make sure you plug this first node into the second node. And then you plug this into the output right there. And hey, that looks much better than what it was previously. Now, if we compare it to the default Unreal Engine flavor by setting the blending mode to difference and turning on this layer on top, it's going to look different. We can obviously see that on the color card, if we maximize our viewport, we can see that the colors are going to be pretty different using this blending mode test, but realistically, it's still pretty close. And if we go to edit and then we turn off the compositing mode and then we set it to normal and we turn it on and off, the colors on the color card are, at least to me as a colorblind artist, almost imperceptibly different. Maybe there's a slight value change, and obviously the background is changing because of the LODs and the render settings, but overall the colors look very close. Now, what about the Rec 709 image? Right now we're currently looking at the EXR DWAA format, and if we turn on Rec 709, the difference is imperceptible. So, with that out of the way, we can see that, hey, look, Rec 709 rendering in ACES works. Okay, now if I set my Rec 709 test image to difference, depending on the monitor that you're using, this will look black. And I've tested this on 2 monitors. I have an LG super wide monitor over here, and then a Dell more color calibrated monitor over here. On the Dell, I can see some very, very slight differences in the color. But if I move it over to my other monitor, these pixels look black. So my point is, almost all of these color differences are so small and insignificant. But if you want the highest color fidelity, render in EXRs. So now what we're going to do is we're going to test all the other EXR sequences to see how they turn out. So let's go over to the color tab, and this first EXR sequence is already set up for ACES. Now what I'm going to do is I'm going to go to my other format of EXR that's rendered in DWAB, right click on the first node and hit apply grade. And now if we cycle between the two, they look identical. So DWAA and DWAB match. Now let's go to the third one, which is rendered in the PIS format. And if we apply grade, we can see they are very close. However, the PIS format has a very, very slight color shift. And I'm going to confess, I have no idea why that's happening. If you look at the background here, you can see very closely. So if I make my viewport for my color a little bigger, we can cycle between the two shots, and they are imperceptibly different. So we can cycle between the two shots, and we can see that there's a very, very slight color shift between the DWAA, the compressed versions, versus the PIS format. Choose your favorite flavor. Doesn't matter. If you don't mind the file sizes and need to do some more advanced things like multi-layer rendering, use PIS. But for most of us who are color grading out of Unreal, ACES with DWAA or DWAB work fine. So now let's talk about this other shot here. This looks way worse than the ACES formats, and the reason why is this was rendered in S-Log3. Now, that is my preferred color profile because of the cameras I shoot on. Let's right-click on this clip and apply grade, and it's going to look real gross, and the reason why is we're not transforming this footage to what we want it to be. First, we know that we rendered this in S-Log3, so we're going to go to our input transform on the first node here and set this to Sony S-Log3 S-Gamut 3 Cine. And then once we change that, it's fixed. It looks fine because we know we rendered in S-Log3, and now we're saying, hey, it's S-Log3, bring it to ACES, and then output Rec 709. Now, if we compare it to the other ones, very small, imperceptible differences. And if we turn on our timeline again, and we turn on layer 3, which was my Rec 709 viewport transform, we can see that, hey, it looks very, very close to those original colors. So, because of that, S-Log3 could also work. You could render in log formats from Unreal if you want to. Awesome. Sounds good, right? Now let's move on to the other format where you disable the tone curve. We are not going to be working with the ACES color space. And when we do that, we're going to see some slight differences. So if we go back to our Edit tab, and we can see the EXR PIS no tone curve, we disable the tone curve for this clip, it still looks like it was rendered in linear or ACEs. It looks contrasty and gross for the artists who don't want to consider the color science nerd stuff. It looks gross, and we want to bring this out of that. So to do that, we're going to go back to our color tab, and for this option, what we're going to do is do the same thing. We're going to apply grade, or you could just add the ACEs transform nodes, but ew, this looks disgusting, and the reason why is we need this to be linear. So we're going to scroll down to the very bottom to sRGB linear, and then we're going to output this also to sRGB linear. And now for the second node, we need to also set this to sRGB linear, and now it looks like a normal shot, right? And if we compare it to the previous shots, very subtle differences between all of these clips here. Now, this clip that I have selected is the disabled tone curve version from Unreal Engine. If I were to check my Rec 709 image and I turn on layer 3, we can see that there is a very obvious color chip that has a very significant color shift. Or rather, it's a very small color shift, but for the difference mode, it actually makes the pixels look different. So what does this mean to us as artists who are just trying to get the most color accuracy? If you turn off this node and you compare that chip, this one right here, to the ACEs workflow, and then we go back to this clip, which is the disabled tone curve, there's some differences in the greens and the yellows, and overall the ACEs color space has a wider gamut or more colors to work with, especially in the greens and yellows. And you can find this in William Foucher's YouTube channel on his ACEs video. There's definitely a color difference in the yellows and greens. To me, as an artist who's colorblind, I cannot tell the difference. So you pick your favorite flavor of ice cream. Do you want to disable the tone curve or work in ACEs? I prefer ACEs. Now what I want to do is look at this last one, which also looks like it's rendered in linear. However, we did not do any color output transforms, and we did not do any ACEs things to it. It is just what Unreal set for the 16-bit EXRs. So if we were to try and get this out of this gross linear space, and we go to the previous clip here, and we right click and apply grade, which is just going to copy the same nodes from the last one, it looks like it's fixing it, but there's something weird happening, and I'm going to confess, I have no idea what. But what I do know is that these skin tones on the character look a little bit washed out, a little bit just weird. And if I go back to the previous clip, which was rendered without the tone curve, we can see that there's definitely something weird happening. And I don't know what that is. And I did a lot of research and I still can't figure it out. So someone way smarter than me can let me know in the comment section down below about what's happening with the EXRs. All I care about is I want my viewport to match and I want it to look good. So now let's compare this to the Rec 709 image, because really we're going from linear to Rec 709 and compare that. And we can see that those colors are much more different. They're less black than the other counterparts. So the EXR brethren rendering in ACEs, in DWAB, PIS, DWAA, or without the tone curve just are better. For your EXR sequences, you should really consider adding the color output option. Granted, it also doesn't look all that different. Like, some of the color differences are imperceptible. But if we scroll to the other clips, they definitely look better. Now, before we go any further, I do want to make one small confession. Unreal did crash while I was going through this science experiment, so I do know that my slog3 render does look a little bit better, I will say, than the other EXR counterparts, but overall, these colors are very close. So my point behind all of the EXR sequence ranting that I'm doing is render in EXRs, do some color output settings, either disable the tone curve or work in ACEs. Now, we can move on to the other file formats that are smaller and generally something I get asked a lot of questions about. Can I render in PNGs? Can I render in AppleProRes or JPEGs? Sure, but you're going to make some compromises. Let's talk about that. There are some differences when it comes to working with 16-bit EXRs and 8-bit PNGs from Unreal. First, we have this shot here that is a PNG sequence that's rendered in ACEs. And if we turn on this second layer here, we can see that it's pretty close. We can see that these colors and most of the pixels are more black, which means those pixels are closer to matching. But we're in the ACES color space for this image, and we want to make it not that. We want to be in Rec. 709. So we're going to take the previous grades that we made on the EXR sequences, right-click, and apply grade. We'll add these nodes. We're inputting and outputting ACES CG. And then for the second node, we're getting input ACES CG, output Rec. 709. These skin tones look weird and gross, and I don't like them. And if we compare this to the EXR sequence right here, we're definitely getting some color shifting. And if we enable the Rec. 709 comparison, we can definitely see, especially on the face up here, some of those colors don't match. Sure, it looks a little bit more black on the colors, but we're getting some weird results by converting from a PNG sequence in ACES CG into Rec. 709. Because it's 8-bit, that's my assumption, so my recommendation is don't do ACES with PNG sequences. Now, if we go over to our Edit tab, let's double check and see that now the PNG sequence that we're working with is with the disabled tone curve. So that is adding some color transformation. We're getting rid of the tone mapping nerd stuff. So if we compare it to the Rec. 709 image, definitely weird, and these colors are way off. The skin tones are way off. And then the no color transform, it's also going to be off as well. These skin tones are going to be looking different than what it normally is. And then if we disable that no color transform and we maximize it, it looks fine. It looks like a perfectly fine shot. And if we play it back, hey, look, it looks pretty good. And if we come out of the full screen mode, we can also take a look at the PNG sequence without any color transformation whatsoever. That is this shot, and this, if we turn on the no color transform screenshot checker, this is more black. It matches most of the pixels under. So you could theoretically render in 8-bit PNGs and have it match your viewport without any color transformations, and it will look fine. However, here's the problem about rendering with 8-bit PNGs. If I select this PNG sequence without any color transformation, and I hit Alt-S on my keyboard, and I bring up the gain by like, what, 1.48, shot's ruined. Looks gross, looks terrible. But if we go to our ACES sequence, and we select the first node, and we hit Alt-S on the keyboard to add a node in between the ACES transform, and we bring the gain to that same value, it's going to look way different. We can take this shot versus this shot right here, and they are significantly different with the same effect. ACES and 16-bit EXRs are just the way to go if you need to do color grading. So let's reset that, and we can adequately say that rendering in 8-bit PNGs is fine if you don't need to do any color grading. What about JPEGs? So if we go back to our Edit tab and we look at our JPEG no color transform, and we turn on the color transform checker, hey look, it is more black, which means a lot of those pixels match. It looks pretty good as far as I'm concerned. So you could theoretically render out in an 8-bit JPEG without any color transforms and get pretty close to what you have in render and in camera and have a perfectly fine workflow. But if you need to do any color grading with a JPEG, same thing. If you crank that value even just a little bit, that image is gross and less good. So if you want more room for color grading, don't render in JPEGs. But if you're cool with in camera, sure, JPEG sequences are fine. What about the other ones? Let's check out the ACES version. If we scroll back to the beginning, right click and apply grade. Now, I realize we did add some grading here, but we can just delete that, and we're back in the ACES CG to ACES CG Rec. 709, and these skin tones look gross. And if we compare the Rec. 709 image, we can see some color shifts happening in the face. The colors on the card look pretty good, but as far as I'm concerned, I don't see why there would be a point to do any color grading in ACES with JPEG, especially when you hit Alt-S and add some color changes to your image. It's going to wash out and just look really weird and gross. So even working in ACES with JPEGs just doesn't work because it is 8-bit. Do not recommend, but you could work with it if you want to. Let's just clear that and get rid of it. And then the last one is the disabled tone curve, and same thing. It looks pretty good still. It looks fine, but again, it's a JPEG. If you were to crank this value at all and add a node and even move up the shadows or the midtones or anything, it's just gonna just wash out that image completely. So I don't recommend working with JPEGs. You could if you want to, but it's shooting yourself in the foot for the highest fidelity color, especially if you need to do color grading. So let's jump back over to the Edit tab, and we're gonna look at the last couple of shots rendered in AppleProRes. Now, I've gotten a lot of requests of how do I render out a video clip from Unreal. I'm just going to say don't. It's buggy. It's unstable. I've had so many issues just trying to get it to work sometimes. Use EXR sequences, especially if your render crashes at a particular point. You can at least pick up where you left off with those frames rather than having to redo the entire shot. So AppleProRes, if I select this clip, you're going to see some nightmare fuel. Ew. Gross. I have no idea what's happening on the back end. But this shot was rendered with AppleProRes from Unreal using ACEs, a .mov file. I have no idea why it's doing this, but I did this multiple times. We can see that it's just doing some weird things when it's trying to convert the AppleProRes into an ACEs color format. So that's bugged, just not going to use it. Go back to the color tab. What about the second shot? And that is the AppleProRes with the disabled tone curve. So we're back in the color tab, and we're going to take this shot right here, which I know is the disabled tone curve version, and this version is also, it looks fine with the disabled tone curve. It looks like it's doing some tone mapping on the back end, whatever that means, and if we apply that, it's just going to look gross and weird. So it looks fine, right? But with the AppleProRes version, if I add a node and I just crank this value, it blows out instantly. I don't know what is happening with this file versus the EXR sequences, but the AppleProRes versions is just not working for me. So someone can correct me if I'm wrong, but I just generally say to people, don't render out in AppleProRes from Unreal. You're going to have more headaches. Now, the last version of AppleProRes is with no color transformations whatsoever. It's just doing its thing. And if we turn on our color checker with no color transform, track 4, we can see that it's really close. And from there, if you really needed to render an AppleProRes shot, you could theoretically render AppleProRes with no color transforms and be perfectly fine. And if you have your animation done in camera, cool. Works for you, then it works for me. Happy for you, man. But I just generally say don't work with AppleProRes. The conclusions of all of this is render in 16-bit EXRs. I recommend ACEs, but disable your tone curve because it's going to give you the highest fidelity. Now, as an example, I rendered out this beautiful landscape shot, and what I'm going to do really quick is just show you the overall pipeline of how to handle a 16-bit EXR, because I understand that a lot of you who are watching this are really watching because you want to make video game cinematics. You want to make something that looks beautiful and artistic. So typically when you render out an EXR sequence from Unreal Engine, what you're going to get is something contrasty and gross. This is a linear color space or an ACEs color space. Something's going to look like this, and it could theoretically pass, but we want to get it out of the ACEs color space. So we're going to add that ACEs transform node to the beginning, set the input to ACEs CG, add the node output ACEs CG, go back to the library, add the ACEs transform again. What we're going to do is add the input to ACEs CG again, and then the output to Rec 709. And then if we plug this in to our output, it's going to look so much better. That's a cool looking shot, right? Now, if you were to color grade this, and William Foucher goes over this in his channel, any color grades that you do need to go in between these two nodes because we're working in the ACEs color space. So if I hit Alt-S on my keyboard, and let's say I just want to brighten it up a little bit, just a touch, just like that. Cool. Awesome. The order in which you apply nodes in DaVinci Resolve and the ACEs color space matters. So if I select this last node here and I hit Alt-S, it will add a node after the ACEs. And what I can do is I can hold Control or Command on my keyboard and drag this on top of the other node, and it's going to switch them. And when we do that, it's going to blow out a bunch of stuff. So the order in which you color grade matters, and color grading your renders is a valuable way to bring some of the shot out of the CG world and make it feel a little bit more real by adding grain and bloom and other stuff. I will say that you could render with some of the post-process volume settings in Unreal Engine, but those are intended more for video games and they're optimized for video games. They don't look as good. We'll get to that in another video. But overall, what I'm trying to say is render with 16-bit EXRs from Unreal. I like Aces. Now let's talk about After Effects, because I know some of you are like, what about After Effects? So we're in After Effects, and I have these two shots in my project. I have the EXR PIS Aces format and the no tone curve version, because these are the formats I generally recommend to most people. We're not going to go through the entire spiel again. This is what I want you to know from After Effects. First off, whenever you open up After Effects by default, it is probably going to be Adobe Color Managed. Generally speaking, you could do this workflow and use some older plugins, but fortunately, in 2023, OCIO and Aces is now natively in After Effects. So we can set it to OCIO Color Managed, and it's going to change some settings in your After Effects project. It's going to set our working space to Aces CG, and it's going to make our display space Aces/Rec 709. So when we set that, hey look, that looks pretty good. Now, I will say, what I did do is I already did interpret the footage correctly, but your footage may still also look gross. What you have to do is right-click on your footage and go to Interpret Footage Main. You're going to go to your Color tab, and Preserve RGB may or may not be checked, depending on the defaults. I'm going to uncheck it and make sure that I'm in the Aces CG color space here. Click OK. Now, this first shot that I have in my After Effects timeline here looks fine. Looks like a normal Rec 709 shot. We can see that by it saying Aces/Rec 709. Now, this other shot right here, let's do the same thing. Right-click, Interpret Footage, Main, Color, and if you disable the tone curve with Unreal footage, you want it to be Utility Linear sRGB, just like the way we worked with in Unreal. So once you set that, you should be good to go. So now, if we play this back, these shots look perfectly fine. Now we need to render this out from After Effects. So I'm going to take these two shots, and I know that I want to take this and hit N on my keyboard to set the out point. I'm going to hit Control M to go to my render settings, and I have this Aces demo file in my render queue, but you have to do one major thing. You have to click on the output module, high quality. This window will pop up. And what you have to do is go to your Color tab and set your output color space. It will default output Aces CG, but we don't want that. We want output Rec 709. Now, I will also mention that I am using the Aces 1.2 config. You could use the Aces 1.3 config. Some of these settings will be different. The final goal is to just make sure you render in Rec 709 if you are working in Aces and After Effects and your final destination is Rec 709. We'll talk about 1.3 in another video. I'm going to go over to DaVinci, and we have my EXR sequences again, and I know that this shot that I rendered from After Effects in Rec 709 was using the EXR PIS format. So if I take this clip and drag it on top of the EXR sequence PIS Aces, no difference at all. If I turn this on, hey look, there is nothing different between these shots. They look exactly identical. And if I set the compositing mode to difference on the very top, it's black, which means all of those pixels match. So science, we're getting somewhere. However, what I will say is if you set the compositing mode back to normal, go back to the Color tab with that After Effects clip selected here, and we were to increase our color, we are baking all of that Rec 709 information in, so we do not have the ability to color grade this shot, even rendered in a .mov format. So my point here is EXR sequences are king, once again. So we can delete that. Let's double check the tone curved version. So we can take this clip, and I know I want it to be on top of the PIS no tone curve. And if I scroll over there, hey look, it's a perfectly fine looking shot. And if I turn this off, I realize I'm off by one frame. So let's just put that right there, and then turn you on and off, and there is no difference or an imperceptible difference. So the After Effects workflow is also a very valid thing for rendering in Unreal. So with all of that out of the way, what should you be doing as an artist that wants to be using Unreal and you want to have the best color fidelity information. I've done a handful of Unreal Engine commercials for a lot of my clients, and most of the time, the biggest thing that they care about is that their brand colors match. And a lot of the time, there might be some imperceptible differences between monitors and screens and workflows. My goal is to try and get my viewport to match my final destination, which is going to be a TV or a phone or something like that. Now, for your convenience, I created a Google Drive download link where you can download the render settings I use for this shot, so then you can add it to your projects. Simply add it to your content folder of your project, and you can render out some beautiful renders. Make sure that you follow the beginning of this tutorial, which is adding your OpenColor IO configuration to Unreal, and go through all that fun stuff. And with all of that out of the way, we are done. I appreciate you watching this overly technical and not super scientific, but I just wanted to brute force figure out color in Unreal tutorial. Thank you again for watching. If you have questions, comments, concerns, comment section is down there for that, or you can just hit me up on Instagram at JohnJagsNey. And I will leave you with the usual final tip, and that is to eat 1 gram of protein per pound of body weight, and you'll make some. Goodbye, my friends. Bye.